Hello everyone, welcome to my YouTube channel. Today I am going to talk about the Topographic Wetness Index (TWI). It is described as the terrain-based index used to estimate spatial patterns of soil moisture and potential water accumulation. How much water is accumulated in the landscape? Usually the TWI talks about these parameters. It combines slope and upstream contributing area to show how topography controls water distribution. And also it talks about the number that shows how likely an area is to collect and hold water based on its slope and how much land drains into it. And the formula used in the TWI calculation is as follows. The ln of A divided by tan beta, where AS is the specific catchment area, meter square per unit contour length. It is the amount of upslope area draining into a point, and beta is the slope angle in radians. Here is the concept. Today I am going to show you how to calculate the TWI in ArcGIS. So I am going to show you the tutorial in ArcGIS ArcMap version 10.8. So I am going to open it first. I have already imported the DEM. Whichever area you can use the DEM. I have used a DEM file of a region of India, in the northern part area of the India, and this is the DEM file of a river catchment. First of all, let's see the steps for the ArcGIS. Here are the steps. There are total 7 steps we can calculate the TWI. First of all, we have to fill the DEM. So let's fill it. You can search here the hydrology arc toolbox. Here you can select this hydrology. Search for the go through the fill. Okay. I'm going to grab this. I'm going to drag this DEM into this input surface raster, and let's get this output in another. I'm going to save this, creating folder name hydrology. DEM fill .tif. Okay. After doing this, I'm going to do for this second number. Here is it is flow direction. Okay. Also search the go for the flow direction tool. Yeah, here it is, and drag this field 1. So also get the output location. I'm going to rename this as flow direction. Flow direction. Okay. After flow direction, we have to calculate for flow accumulation. Let's compute this. And flow accumulation, click on this flow accumulation, and also drag this flow direction file and keep it in the location flow direction, and this is flow accumulation. So I am going to rename this as flow acco. Click OK. And after that, let's see for slope. For the slope, go to the surface arc toolbox, and under this spatial analyst tools, you can get surface. Under this surface also you can go for slope. So click on this slope and drag this file, the field one. I'm going to drag this field one, and let's put in the output location. Let's say it is a slope. Okay, slope.tif. Here we got the slope file also. Now in the number 5 you can see the slope in radians. It is in degree, because I calculated this in the degree. So now for this time we have to calculate the slope in radians. To calculate the slope in radians, here it is the formula. This file is in degree, so this file into 3.14159265 divided by 180. So let's go for this calculation. We have to click on the raster calculator, search for this, and clicking on this, drag this slope. First of all, let's see for the formula. Keep this inside the brackets and click on this multiplication and copy this, or you can manually type 3.14159265. Also this must be in bracket and divide by 180 and bracket. Let's locate this in the output folder. Here we can rename this file as slope in radians. So slope radians. Click on OK. After getting this file also, we can go for another step. Here it is in 6. We need this tan slope. That means this is we can see in the formula also, there is the ln of area divided by tan beta. So we are in this now in this step. So we have to calculate for the tan slope. That means tan beta. Tan slope equals to condition of slope greater than 0, tan slope, and comma in last 0.001. First of all, we have to click on this conditional, and slope greater than 0, tan slope. Let's go for this. Here you have to drag this, the slope in radians. So keep it just before the comma, as it is in the formula also. Slope greater than 0. That means greater than 0, comma tan slope, comma tan, and this slope. I think last one is comma 0.001. Comma 0.001. Okay, let's keep this as tan slope. Okay, tan slope, and click on OK. It will calculate for the tan slope. Here we got this tan slope. Now in the last stage, which is also the formula, it is ln of the area. That means flow accumulation into shell size. So here we have to click on this again, raster calculator, and click on this ln function. Where it is? I think this one is ln, and click on this flow accumulation. Flow accumulation file is here. Okay, flow accumulation into cell size. First of all, we have to see for the cell size. Source, the cell size is nearly 30 meter. Cell size nearly 30 meter. Yeah, okay. Just copy this 29 point something. Oh, sorry. Raster calculator. Click on ln and flow accumulation. Where is that flow accumulation? Here is the flow accumulation and comma, sorry, into flow accumulation into and tan slope cell size. I had already copied that size, so I am going to paste it here and divide by tan slope. This must be in bracket. So this is the cell size and divide by tan slope. Tan slope, and another bracket also we have to put. Okay, and let's rename this as TWI. Click on this. Yeah, this one is the final TWI map raster file. Let's go for the properties and symbology. Let's reclass this as 3 classes, and also do for the color correction. I will put this as low to high, as low as green color and high as red color. Click on apply. Yeah. In this region, I had rescaled, classed as 3 classes, low, moderate and high. And in the lower case, we can see for the green color, and for the moderate color we can see for yellow color, and for the higher class we can see for red color. This red zone is the area where the water can accumulate, and these are the water holding area where the water holds in this region. This must be the river channel also. We had already known this area, so this is the river channel, and these are the other zone where the water may accumulate. This yellow color also has the high chance of water accumulation zone.